Hello and welcome to this Azure App Service application monitoring demo. My name is Denver Britton and I'm a PM on the App Service team here at Microsoft. Today I'll be walking you through setting up application monitoring with your Tomcat business app on Azure App Service. So as a Java developer, after working on a Tomcat business app and after migrating it to App Service, you'll need to monitor the performance of your application from every stage of development through testing and into production. Any tool or platform of your choice can be used, but today we'll be focusing on Azure Monitor, Log Analytics, and App Insights to monitor, identify, and troubleshoot any issues with an application running on App Service. Azure Monitor allows us to create and respond to alerts on availability, performance, and errors for seamless end-to-end monitoring and application troubleshooting when needed. By aggregating end-to-end application performance monitoring data into Azure Monitor dashboards, you can visualize the performance of your app in real time. So a quick look at the application itself. We have a basic bookstore app made using Java Tomcat and hosted with Azure App Service. This is meant to model a standard business application with authentication and database access. Quick note about the environment. This environment was created using Landing Zone Accelerator for seamless creation of our app service and our Log Analytics workspace that we'll be using for this demo. So before looking at the portal, let's look at Logstream. Logstream can be accessed through the Azure CLI for quick access to streaming application logs when needed. If we need to perform a quick test or inspect some current logs, the CLI is a really great place to start. Developers can focus directly on the Tomcat app itself, for example, monitoring the log stream following a migration of an on-prem app to App Service. This can help the developer ensure that everything is functioning properly behind the scenes, even uncovering issues that may not be visible in the app UI. The command to inspect the log string of our application is azwebapp logtail, specifying our resource group and our application name. After running this command, let's generate an error by attempting to access a page that doesn't exist, forcing our web app to send a 404 response, which will then be captured and streamed to our CLI logstream app output. While this might be a benign error, Logstream will capture all application errors and stream them via CLI straight to the developer working on the app. Let's switch to the portal now and take a look at Azure Monitor. Azure Monitor is a comprehensive monitoring solution for collecting, analyzing, and responding to monitoring data from your cloud and on-prem environments. It offers a number of different tools to help you understand how your apps are performing, any issues they may be having, and allows you to manually or automatically respond to events needing attention that could potentially impact the availability of your application. So let's start by looking at Log Analytics. A Log Analytics workspace allows us to easily edit and run log queries against data in an Azure Monitor log store. In this example, these logs will be application and system logs from our app service, but they could be anything stored within an Azure Monitor log store. Log queries can allow us to retrieve sets of records, perform complex statistical analysis, and even create visualizations of log trends, all within this Log Analytics dashboard. So a basic log query might look like this example. This will show us all the error level logs within the past 24 hours from our app service, specifically within app service application logs. We can adjust our time range and even adjust the number of rows returned by slightly editing our log query. If you're familiar with Kusto, log queries may look familiar because they use the same KQL language as Kusto. This means there is a wealth of knowledge from Microsoft on troubleshooting any log queries as they use the well-established KQL language. Next up, let's make an alert rule. Let's assume that we've played around with multiple different log queries and we found something that's extremely insightful and needs to be shared anytime the log query returns at least one row of data. This is where alert rules are helpful. We can make one directly from our log query, and anytime this log query returns data, our alert rule action will fire, and if configured, we'll send data to the appropriate location. This could be an on-prem SOC for security concerns, an application monitoring team to investigate performance concerns, or even a development team that needs to investigate app errors surfacing from the alert rule. To make this alert rule, we're going to select Create, and then under Signal Name, we're going to select a custom log search. This is where you can get creative and engineer your log query to handle anything you need to monitor in your environment or for your application. In this case, we're going to use our same query from before to grab all the console log errors from our app service. After creating our query, then we need to set our alert logic. In this case, we want one or more alert triggers within a 5-minute window. Now we just need to give our alert rule a name, and then we can proceed with deployment. Now every time a console error occurs on our app service, we'll receive an alert to our Log Analytics workspace. Now let's switch over and take a look at App Insights. App Insights application performance monitoring features give development teams the ability to monitor applications from development through testing and into production by proactively understanding the current performance of the app and by reactively understanding the app execution data to determine the causes of incidents during after-the-fact postmortems. App Insights gives us a few key features, including live metrics, highly granular performance monitoring, and GitHub or Azure DevOps integration to seamlessly integrate into work items and enterprise CI/CD pipelines. So let's take a look at the application map first. App Insights makes it really easy to visualize a map of your application and its dependencies. In this case, we can see the SQL database associated with our Tomcat application. Looking at the performance blade now, we can see all of our app operations. And just like our application map, we switch to dependencies. We can see our database interactions where we can even drill into logs directly to troubleshoot problems and view end-to-end database transactions. Drilling directly into this database log allows us to see our transaction and view the exact SQL query responsible for this log. Live application metrics are also easily accessible on the Live Metrics blade to show you the current status of your application at any given time. Application Insights makes it easy to monitor your app at every stage of development and through release into maintenance and modification, with support for all available Java stacks on App Service, including Tomcat, Java SE, and JBoss EAP. Using Logstream, Log Analytics, and App Insights, developers can effectively monitor and respond to issues in real time on any App Service application, all the way from testing into production. For more information on Azure Monitor, take a look at aka.ms/appservice/monitor. Azure App Service makes it easy to deploy and scale highly available enterprise-grade code apps or container apps without having to worry about infrastructure. With Azure Monitor, Log Analytics, App Insights, and Logstream, monitoring your application on App Service is easy and seamless.